All right, let's just dive right in. Welcome to today's Explainer, where we are totally skipping the usual pleasantries because honestly, we're jumping straight into the deep end of a high stakes emergency. I want you to imagine this for a second. You wake up in the middle of the night, your feet hit the floor, and instead of your warm carpet, you step into a cold, creeping pool of water. Instant panic, right? But what is actually happening beneath the surface, behind your drywall, and inside the very bones of your home? Well, today, we're basically tearing down the walls to look at the exact anatomy of a flood and the surprisingly strict, fascinating science of water damage restoration. Check out this number 1, just 1. Water spreads at roughly 1 inch per hour across flat surfaces. And guys, that is the ticking clock of our entire disaster narrative today. When water breaches your home, it's really not just a static puddle waiting for you to grab a mop and bucket. It is a highly mobile, creeping force. It constantly seeks the absolute lowest point, moving silently and just relentlessly soaking literally everything in its path. There's this quote that really hits the nail on the head regarding the harsh reality of floods. Every hour you wait means more square footage affected, more materials ruined, and higher restoration costs. Ignoring water damage, even for just a few short hours, allows this invisible enemy to migrate deeply through floor joists, seep into insulation, and wick right up into wall cavities where you can't even see it accumulating. That aggressive, creeping spread is exactly why professional restoration crews aim for a 60-minute dispatch guarantee. 60 minutes, because that first hour literally dictates your total damage exposure. Now, I'll be honest, this window is incredibly hard to hit because human nature just kicks in and we panic. We run around, we grab every towel in the house, we try to clean it up ourselves, and we waste incredibly precious time. But if professionals can get their wheels rolling and get on site within that golden window, like before you even start soaking your good bath towels, they can stop the progression dead in its tracks. Speed matters more in those first few hours than absolutely anything else. Okay, moving right along to Section 1, Ground Zero, Why Homes Flood. To figure out how to fight the water, we first really need to understand how it gets in. Let's look at Norwood, Ohio as our real-world case study, because its unique geographical and architectural profile basically creates an absolute perfect storm for water intrusion. So Norwood sits right in the Mill Creek watershed, which means seasonal storms hit the area super hard. Add to that these heavy clay soils. Clay soil acts like a giant sponge that just refuses to wring itself out, right? It retains water right up against your home's foundation instead of naturally draining it away. Then, factor in aging pipes that frequently crack from the inside out during those brutal winter freeze-thaw cycles. And finally, the older homes here, we're talking built between the 1920s and 1960s, heavily feature pier and beam foundations. That means the house is elevated on wooden posts, creating this dark, unsealed crawl space underneath, which is basically a perfect trap for moisture to sit and wick directly up into your floorboards. But how the water actually breaches completely changes the dynamic of the disaster. On the one hand, you have a slow foundation leak. Heavy rains completely saturate that clay soil we talked about, building immense hydrostatic pressure. Think of hydrostatic pressure like a giant water balloon being relentlessly squeezed against your brick foundation until the water is physically forced right through hairline cracks in the mortar. It's this super slow, insidious buildup. On the exact opposite hand, you have a sudden sump pump failure. When a massive storm overwhelms your drainage system or the power just cuts out, a failed pump can instantly dump hundreds of gallons of water directly onto your basement floor in a matter of minutes. Totally different beasts. That brings us to Section 2, Know Your Enemy, the 3 categories of water. This is where the science really kicks into high gear, because all water is absolutely not created equal, and the type of water completely dictates the scientific and safety response required to clean it up. So, Category 1 is clean water. Think a burst freshwater supply line. It poses a minimal health risk. Simple enough. Category 2 is gray water. This comes from sources like a washing machine overflowing, so it's carrying some level of soap and biological contamination. But Category 3? That is black water. Think raw sewage backups or storm floodwater. A really good rule of thumb here, if you wouldn't swim in it, you absolutely shouldn't be breathing near it. Dealing with Category 3 requires full-on hazmat-level protective equipment. Every single unsolvable porous material this water touches, drywall, carpet, your insulation, it all has to be completely ripped out and the whole area treated with heavy-duty EPA-registered disinfectants. So the absolutely crucial point here is this. Using Category 1 protocols on Category 3 water creates incredibly dangerous living conditions. You literally cannot just mop up a sewage backup and point a box fan at it. Treating toxic black water like a simple pipe leak leaves behind microscopic, illness-causing pathogens that can seriously, seriously harm your family. All right, Section 3, the science of drying. This brings us out of that initial chaotic, panicky phase and into the hyper-methodical phase of recovery. Because the actual science of drying isn't just about making things look or feel dry to the touch, it's about verified physics. Professional restoration relies on the IICRC S500 standard. Now, this isn't just a friendly suggestion. It is a super strict, highly technical rulebook that guides literally every single move a professional crew makes. It ensures that restoration isn't just guesswork, because improper drying causes structural rot and hidden health hazards that might not even emerge until months later. This standard dictates that professionals have to scientifically measure, document, and verify every drop of moisture. So what are they actually measuring for? Well, 15% is the magic number for wood. That's the maximum safe moisture content threshold for wood framing. Why 15% specifically? Because fungi and mold simply cannot biologically grow in wood that is below 15% moisture. It's just science. Restoration crews will keep their giant machines running continuously until their calibrated moisture meters confirm that the framing lumber and subfloors have dropped to that exact threshold or even below it. But concrete? Oh, concrete is way more stubborn. It has to be dried down to an incredibly strict 4% moisture content threshold. You can't just slap a concrete floor with your hand and go, "Yep, feels dry to me." The moisture hides deep, deep within the porous material. Crews actually use a calcium carbide test, which literally causes a chemical reaction with the hidden moisture to give an exact, undeniable percentage of how wet the concrete actually is. To hit those incredibly strict numbers, these crews basically treat your house like a tactical military operation against the water. I mean, they bring in the heavy artillery. We're talking truck-mounted extraction units pulling thousands of gallons per hour, thermal imaging cameras that let technicians literally see the hidden moisture trapped behind your walls in real time, which is pretty wild. And then there's the calculated pairing of commercial dehumidifiers and air movers. Basically, the air movers vigorously pull the moisture out of the materials and into the air, and then the dehumidifiers rip that vapor right out of the atmosphere. Which brings us to Section 4, the mold countdown. Because while all that highly technical drying is happening, there is a secondary threat ticking away in the background. The exact moment the flood begins, the mold countdown starts. Within just 24 hours, microscopic mold spores begin to colonize, especially if it's a warm, humid environment. By 48 hours, your structural wood actually begins swelling, buckling, and permanently warping. And by 72 hours, oh man, you are no longer looking at a simple cleanup job. You are facing a massive, incredibly expensive mold remediation and structural rebuild project. Speed is quite literally your only defense against this timeline. And finally, Section 5, surviving the aftermath. This brings us to the final, and let's face it, often overwhelming phase of the disaster, dealing with the costs and the long road to recovery. It's literally the first question everyone asks when they're standing in a flooded room. Why on earth is this so expensive? The answer really lies in the infiltration. Water travels through walls, under your floors, into insulation where you can't even see it. The hefty price tag comes from the intensive labor, the industrial equipment rentals, hazardous material disposal, and that multi-day monitoring required to track down and eliminate every single drop of that hidden moisture before it literally rots your home from the inside out. To put a real number on it, the national average claim cost usually sits between $3,000 and $10,000. But keep in mind, if you ignore that 60-minute golden window we talked about earlier, the damage absolutely skyrockets. If you're dealing with Category 3 black water, or if the water has just been allowed to spread across multiple rooms and floors because you waited to call someone, that claim can easily push past 15 grand. So recovery actually follows a super strict sequential path. Step 1 is emergency extraction, usually happening in the first 4 hours. Step 2 is structural drying, which takes a solid 3 to 7 days. Step 3 is daily documentation. And finally, Step 4 is complete reconstruction. The absolute most crucial thing to understand about this 4-step path is that none of these steps can be rushed or skipped. If you try to jump straight to reconstruction and rebuild before the structure is bone dry, you will fail inspection, and you will 100% guarantee future mold. Navigating all of this is frankly a massive headache, which is exactly why professional restoration companies essentially act as your shield against insurance denials. They handle all the complex evidence required to actually get a claim approved. They maintain the daily moisture logs, they take comprehensive photo documentation, they even generate Xactimate estimates, which, by the way, is the universal standardized pricing software that insurance companies actually use themselves, so there's zero arguing over the cost of a square foot of drywall. And a lot of times, they'll just build the carrier directly while negotiating the entire scope of the damage right on your behalf. If there is literally one core takeaway you remember from all this data today, let it be this. Delaying mitigation turns a manageable issue into a total rebuild. The cost of waiting, whether you're just, hoping it dries on its own or you're putting off the phone call to grab a few more beach towels out of the closet, it always, always exceeds the cost of immediate action. So I want to leave you with something to really chew on regarding your own home's vulnerabilities. If water breached your foundation tonight, do you actually have a plan for those crucial first 60 minutes? Because as we've seen today, that clock starts ticking the very second the water hits the floor. Thank you so much for joining me for this explainer, and hey, stay dry out there.